This next question should be solved using a Venn diagram, not a tree diagram, because it's not this happens, then this happens. A Venn diagram would be more appropriate. And once again, our events are not going to be mutually exclusive because there are probably going to be freshmen IAU students that live in the resident hall that have a phone plan through AT&T. What we have here is one of the events that represents living in the residence hall, and the other event that deals with their phone plan. And then all of it represents the freshmen that are at IU. And so, what we have here is it says one of the key words right here that they are independent. Okay, so there's a formula for independence. You don't have to have it memorized, but that formula for independence says that the probability of the two events, so A and B, or I guess in this case I could replace that with R and P. But anyway, this is the formula. The probability that A and B is equal to the probability of A times the probability of B. So in our case, this would be the probability of living in the residence hall and having that phone plan through an AT&T is equal to the probability of living in the residence hall times the probability of that phone plan. And in this case, what are we given? Well, we are given that the probability of living in the residence hall, 80% of freshmen plan to live in the residence hall, so 80%, so that's going to be 0.8, and 60% have their phone plan through AT&T, so that's going to be 0.6. So if you multiply those together, that's going to give us 0.48. And again, this is the formula for independence, so we know what both of those probabilities were, and this is giving us what the probability of the overlap, the intersection is. So right here in the intersection in our Venn diagram, we know that this is 0.48. And then we can work from there. We know that 60% have their phone plan through AT&T. So that means that all of this right here, all of this circle P adds to 0.6. So 0.6 minus 0.48 would give us 0.12. And then for the residence hall, we know that all of this is 0.8. So 0.8 minus 0.48 would give us 0.32. And then 100% of the freshmen, okay, that's what the box represents, the universal set. So 1 minus everything that's in the circles would give us 0.08. All right, so our answer lies within here, but what is the question? It says, find the probability that a randomly selected freshman lives in a residence hall or has an AT&T phone plan, but not both. All right, so what this is asking for is that they live in the residence hall or they have that AT&T phone plan, but not both. So that's going to be 0.32 plus 0.12, which would give us that answer of 0.44. So 44% either live in the residency hall or have that phone plan, but do not have both. This next one, once again, would be well set up with a Venn diagram. One of the events representing that Homer is watching Monday Night Football, and the other event that he is eating pizza. All right, so going through what it says he does both with a probability of 0.25. So remember, for Venn diagrams, you always try to fill out the innermost first and then work your way out. So if it says that he watches football, Monday Night Football, with a probability of 0.6, that's 0.6 minus 0.25, which would give us 0.35. And then eating pizza, the probability is 0.45, so that's minus the 0.25, which would give us 0.2. And then all of this needs to add to 1, so outside would give us 0.2. When you call him on Monday night, you learn he is watching Monday Night Football. What's the probability he's having pizza? So what we're trying to figure out here is what's the probability that he is having pizza given that he's watching Monday Night Football. So this is conditional probability, which means that conditional probability formula would be perfect for us. And so that is going to be the probability that he's having pizza and watching Monday Night Football, divided by what is the condition, what we know already has to happen, which is the probability of watching Monday Night Football. So we just need to look in our Venn diagram for these specific probabilities. The probability of watching Monday Night Football is all of this, which is 0.6. The probability that he's watching Monday Night Football and eating pizza is 0.25. So this would be 0.25 divided by 0.6, which you can use a calculator for to simplify, either to put that into a fraction form or to put that as a decimal. All right, the next one. This one would be best with a tree diagram, and so I'm going to pause the video and make that tree diagram. So here is the Venn diagram that I created. The first car can either be Toyota or Honda, and then from there, Toyota, Honda, Toyota, Honda. And I guess I am making the assumption that there is no replacement on this. And so these probabilities then that I came up with were how many total cars were there and how many of those were Toyota, how many of those were Honda. So on the initial one, we have 5/9 and 4/9. But then on the next draw, okay, the first car has already been decided. So that means there are only 8 total cars. Had a Toyota already been taken, then that means 5 minus 1 would give us 4/8. No Honda had already been taken, and there were 4 original Hondas, and so on. So this is a conditional probability tree. And the individual probabilities, so this would be, what's the probability that you have a Toyota on the third car, given that the first 2 were Toyotas? That'd be right here. But this probability is saying what's the probability of getting a Toyota, followed by a Toyota, followed by a Toyota. So this is the and probabilities. And so and means multiplying all of these together. And what I did then at the end to make sure that I most likely set up my tree correctly, I added all of these up and I got the probability of 1. So this has everything that I need. Now I just need to figure out what am I going to take away from this Venn diagram. So the question said, 3 cars are selected at random. If both makes are included, find the probability that exactly 2 are Hondas. So the condition is that both makes are included. All right, so that means it could go Toyota, Toyota, Honda. It could be Toyota, Honda, Toyota, Toyota, Honda, 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 Toyota, Toyota, Honda, Toyota, Honda, 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 Toyota. The only ones that it can't be are these 2, where it's all Toyotas or if it's all Hondas. So it's up to you how you want to approach this to get the denominator. You can either add up all of the possible routes where both Toyota and Honda are included. So if you add all of these up, this should give us our denominator. Or you could simply take the complement. So 1 minus 5/42 minus 1/21, and that gives us 5/6. So same thing. Either way you do it, either adding up all of these, or if you take 1 minus this, we should get 5/6 for our restricted denominator because we have a condition. And then the numerator, it says find the probability that exactly 2 are Hondas. So exactly 2 are Hondas. Now I need to go through and look to see when I have exactly 2 Hondas. So if I do this route, this is Toyota, Toyota, Honda. That's 2 Toyotas. I'm looking for 2 Hondas. So here is a case. I'm going to circle now. So here's a case when I have Toyota, Honda, Honda. That's exactly 2. Here's another route where I have exactly 2 Hondas. And here's another route where I have exactly 2 Hondas. Okay, everything else isn't exactly 2 Hondas. So I have this or this or this. So I take 5/42 plus 5/42 plus 5/42. Or I can just take 5/42 and multiply that all by 3, since I have 3 of those. And what I get is 5/14. So then I can take 5 out of 14 divided by 5 out of 6. And that gives me 3/7. This next one also calls for a tree diagram. I know it says 2 mice are selected simultaneously, but you could think of it as taking out one mouse and then keeping it out and then drawing out another mouse. So there's that process that goes on. So the very first one, hold on a second. Sorry about that. So what I did was then I made a tree diagram to represent this. So here we have a gray male, we have gray female, we have white male, and then I put the probabilities down with these. So let's say the first mouse was a gray male, then that means that there are 7 mice total. Only one of them left would be a gray male, and so on. So what I did then is got those and probabilities and all of these together add up to be 1. So the question says, find the probability that at least one mouse is a male given that exactly one is gray. So what we're doing is we are restricting our denominator to the fact that we know exactly one is gray. So what we're going to do is we are going to look at the cases only when we know that exactly one is gray. So this would not be included because it'd be a gray male with a gray male. We know exactly one is gray. So here is where we have exactly one gray. Sorry about that. Sorry again. But this one right here would be included because it's gray with a white. This would be gray, 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 gray. We don't want those. Exactly one is gray. That's what we're restricting this to. And so this one would be exactly one is gray, and this one would be exactly one is gray. So this is going to be our denominator, this or this or this or this. So what we need to do is add up all 4 of these, which plugging that into a calculator gives us 15 out of 28. So that's our restricted denominator based off of the condition that exactly one is gray. Now the numerator means that I'm working within this space now. Okay, so I'm only working within this restricted space. So I have to pull my probabilities from these starred. But which ones are included in my numerator? It says find the probability that at least one mouse is a male. So now I'm going to go back through and circle when are they a male. So at least one mouse is a male. This is a male with a male. That means that that's 2, which is at least 1. So that would be included. Here's a female with a male. At least one male there. That's included. Male, male. That's 2 males. That's at least 1. And male, female. So all of them, which means it's going to be 15 out of 28, which would reduce to 1. The next one is best solved by using a Venn diagram. We have the events seat, instruments, pedals, and then we have some overlap. So remember with a Venn diagram, in this case has 3 vents, always start with the innermost. So all 3, that's where I'm going to begin, and that's going to be 0.08. Okay, so then I'm going to be looking for exactly 2. So seats and instruments. So seats and instruments, these 2 together will make, seats and instruments will make 0.22. So 0.22 minus 0.08 will give me 0.14 right here. So I've used this one. I've used this one. The next one, we have seats and pedals. So seats and pedals, that means that these 2 together needs to add to 0.18. So if this is 0.08, this one would be 0.1. Let's see. None of the 3 is 0.39. So if I put a box around all of this, none of the 3 is 0.39. And pedals is 0.28, so all of this adds up to 0.28. I can't finish this because I don't know what this is right here. So I've come to a spot where I need it, but I don't have it, so I'm going to use a variable. I'm going to use x. That means that this, all of these circles, right, or not circles, but this total circle for p adds up to 0.28. So if I take 0.28 minus 0.1 minus 0.08, that's going to give me 0.1, and then I'll subtract whatever this value is if I was given this value. And then 0.42 for instruments, so 0.42 minus 0.14 minus 0.08. That's going to give me 0.2 minus x. And then for seats, that's 0.35 minus these that I'm given, which I can actually do that one. So 0.35 minus 0.14 minus 0.08 minus 0.1, and that's going to give me 0.03. All right, so I have an equation that I always know that my universal set, everything that's a subset, adds up to 1 within it. So if I take 1 minus the 0.39, and then if I take 1 minus the 0.39, then that's going to give me what should add up in my circles too. So if I take the 1 minus the 0.39, I'm given 0.61. So I know everything in my circles adds up to 0.61. So one thing I could do is I know all of this circle S is 0.35. So I've included everything in the circle S right now. So now I just need to add together everything that's not in circle S, which is the 0.2 minus the X plus the X plus the 0.1 minus X. And so then I need to go through and solve this equation. So the minus X plus X will cancel out. That will give me 0.61 minus 0.35 minus 0.2 minus 0.1, which will give me negative 0.01 is equal to negative x. So 0.01 is equal to x. And then going from there, hold on just a second. Sorry about that. I did my calculations wrong. I was trying to do two things at once and typed them into the calculator wrong. 0.61 minus 0.35 minus 0.2 minus 0.1 is actually negative 0.04. So this is going to give me 0.04 for what x is equal to. So then I can go back through and I can plug these in. So this one is 0.04. This one would be 0.16. And then this one right here would be 0.06. All right, so now I have everything filled out in my Venn diagram, and now I just need to figure out what's going to answer the question. So what is the probability that it evaluates favorably exactly one of the items? So exactly one, that means I'm looking right here, or right here. That's where we have exactly 1. So 0.03 plus 0.16 plus 0.06 would give me a final answer of 25% or 0.25.